The physics of tennis. How motion, spin, and airflow shape the game. Introduction to tennis. Tennis is a fast-paced sport where players use a racket to hit a ball over a net. The game relies heavily on speed, spin, control, and precision. These elements make tennis a perfect example of physics in action. Why physics matters in tennis. Physics explains why shots curve. What makes topspin dip? Why slices float? And how serves can reach more than 150 miles per hour. Physics plays a major role in every shot in tennis. It explains how players can control speed, how fast the ball travels, spin, topspin, slice, and curve. Direction, where the ball goes. Bounce, how the ball reacts on the court and racket. Forces acting on a tennis ball. Gravity pulls the ball downward towards the court. Normal force pushes upward on the ball when it bounces. Air resistance slows the ball down as it moves through the air. And Magnus force causes the ball to curve, dip, or float depending on its spin. Turbulent flow. Turbulent flow causes air to stick to the ball longer. It increases players' control of the ball. It increases drag as it flies through the air. And it enhances spin on the ball. Reynolds number. The Reynolds number predicts whether airflow is smooth or turbulent. Above is the equation for a tennis ball set equal to 2300. The speed must be greater than 1.3 miles per hour. Fast shots have a high Reynolds number. Slower shots have a low Reynolds number. A typical professional serve has a Reynolds number around 250,000, meaning strong turbulent flow. Topspin versus backspin. Topspin creates a downward Magnus force, resulting in a sharp dip. Benefits of topspin include hitting harder while keeping the ball in, higher net clearance, and a bigger bounce on the court. Backspin creates an upward Magnus force, creating a floating shot. Effects of backspin are that it slows down the ball, it makes the ball skid low, and it's hard to attack. Racket-ball interaction. Spin is created by the racket angle, a brushing motion, string friction on the ball, and swing speed. More friction results in more spin transfer. The diagram shows the angle of the head of the racket before contact with the ball, yellow lines, during contact, green line, and after contact, red lines, to create topspin. Newton's laws. Newton's first law, inertia. A tennis ball keeps moving until something stops it, like the air, the ground, or a racket. Newton's second law, force equals mass times acceleration. The harder you swing, the greater the acceleration and the faster the ball. Newton's third law, when the racket hits the ball pushes back on the racket with an equal force. Energy in tennis. Potential energy, when players toss the ball up for a serve or when the racket is pulled back. Kinetic energy, when swinging the racket, and when the ball is flying through the air. Energy transfer, the racket strings store and release energy into the ball when you hit it. Court physics. Grass. fast speed and low bounce. Hard court, medium speed and medium bounce. Clay, slow speed and high bounce. Conclusion. Physics explains how tennis players control power, direction, and spin. Every serve, forehand, volley, and lob is a science problem in motion. Understanding physics helps players hit smarter shots. Sources. Thank you for watching.